Okay, this video goes over lesson 1 from unit 6 on scatter plots. Okay, so it starts off by saying, does studying for a math test really help your score? In science and other areas, we often want to determine if there is a relationship, linear or otherwise, between two variables that we measure. To initially see the relationship, we plot the ordered pairs of measurements on what is known as a scatter plot, a graph of a bunch of plotted points. Okay, so this table shows the data for 15 8th grade students at Woodland Middle School as to their final exam scores in June 2019 and the number of hours they spent studying. So the first student spent 1 hour studying and got a 50. When you spend 2 hours studying, he got a 70. This one also spent 2 hours studying, got a 68, and so on. So we're going to graph these. So 1 hour studying gives us a 50. 2 hours of studying gives us a 70. 2 hours of studying gives us a 68. 3 hours of studying gives us a 60. The person who studied for 4 hours got a 55. The other person who studied for 4 hours got a 75. 5 hours got a 90. 6 hours got a 70. 6 hours, they got an 80. Oops, that's the 80. This is 70. 7 hours studying, they got a 75. 7 hours studying, they got an 80. Someone who studied 7 hours got a 90. Someone who studied 8 hours got an 85. Someone who studied 8 hours got a 98. And someone who studied for 9 hours got a 95. Okay, and that is our scatter plot. So does studying for a math test really help your score? Well, if you look at the trend of this scatter plot, it is headed upward. This is what we call positive correlation. The more hours you spend studying, the higher your final exam score is overall. Okay, so this was a positive association or correlation between the two variables because the number of hours spent studying increased, the final exam score tended to increase as well. So as the hours increased, so did your score overall. An outlier is any point that goes against the general trend. We can also have negative association or correlation, which occurs when one variable decreases as the other increases. Okay, so positive versus negative. So you see that this trend is headed downward, so that would be negative. This trend is headed upward, so that would be positive. This trend is also headed upward, so that would be positive. And this one is headed downward, so that would be negative. All right, so remember, this is an example of a positive graph, and this for negative, for slope. So you can use that to help you. Okay, key idea. In the scatter plots for A and B above, the graph would be best fit with a line where about the same number of points would lie above the line as below the line. In the scatter plots for C and D, right, so these two they're saying would be best fit by a line that could go straight through them. For C and D, it would be better fit by a nonlinear curve. If you drew a straight line, it wouldn't really balance out nicely. So for these two, C and D, a curve would represent them better. Okay, when finding the line of best fit by hand, different students may arrive at different answers, and a calculator can use a method called linear regression to find the precise line of best fit. Okay, so let's talk about line of best fits a little bit more. If you look at this example, a line of best fit goes right through the points where about the same number of points is above the line as below the line. It goes right through the middle. So that does not go through the middle of our data points. That does not go through the middle. That is above all the data points. But this one, you'll see there's 1, 2, 3, 4, 5, 6 above the line, and like 1, 2, 3, 4, 5, 6, 7, 8 below the line. 6 and 8, pretty similar. The line even goes through some of them exactly. So that's our best line of best fit. Okay, now we have to circle if the relationship is linear or nonlinear. And then if it's linear, we're going to draw a line of best fit. Or if it's nonlinear, a curve of best fit. So this would be nonlinear because it's curving. So we can't draw a line of best fit. This one is linear, and we can draw a line of best fit. It's going to be a line that goes right through the middle as best you can. Something like that. And this one is nonlinear. We would have to draw a curve. So let's go back and draw the curves now. A curve that goes right through the middle of them as best you can. Those are our lines of best fit. Okay, now we have a hot problem. Will every set of data show a relationship between two variables on the scatter plot? So no, we might not have a positive trend or a negative trend. So for example, like when we were doing hours of studying to see what your test score was, maybe we got a scatter plot that looked like this. This doesn't have an upward or a downward trend, so this would not have a relationship. So sometimes you could have no relationship. No, it is possible to not have a relationship between the two variables. Okay, and let's see if we can think of an example of what would cause no relationship. Let's see. Let's say number of pets a student has. And let's say that that's determining their test score. The number of pets a student has is not going to have an effect on their test score. That doesn't have a relationship, so you would get a scatter plot that looks like this probably. Okay, last one. Clark Middle School wanted to visualize the association between how many days a student is absent with what their overall GPA, grade point average, was from 6th to 8th grade, like their average. The results for 80 students are shown on the scatter plot below. Right, so like a student who was absent 10 times maybe had like a 90, a student who was absent like 30 times had this score, and so on. A line of best fit, draw a line of best fit, so that's going to go right through the middle of the majority of our points. Something like that, right? We have about the same on top and below the line. Okay, so we did that. Which type of association? So this would be a negative association because the line is headed downward. Explain why this type of association makes sense. This makes sense because when you are absent, you miss lessons in school. So it makes sense your GPA or average would be lower. As your number of absences increases. Okay. And is there an outlier? So an outlier is a data point that doesn't really follow the trend of the graph. So right here, this is our outlier, where this kid was only absent 3 times, but yet their average was pretty low. It was only like a low, again, like a 72. So that did not follow the trend because everyone else who was only absent of like a few times, like 2, 3, or 4 or 5 times, had higher averages. So that would be an outlier that doesn't really follow the trend. All right, and that is our lesson.